Hello, and welcome to Cloud on Air Live webinars from Google Cloud. My name's Owen Carroll, and I'm an infrastructure technical curriculum developer here at Google Cloud. You're watching a hands-on presentation to introduce Google Cloud to AWS professionals. Over the next hour, we're going to look at Google Cloud and the services that we offer. We're going to go through a couple of demos of our products and get you familiar with their basic functionality. And with any luck, link them back to products in AWS that you may already be familiar with. Our goal is to bring you through the interface of Google Cloud and to get you comfortable with the basic elements. We hope that by the end of this session, you will feel confident in exploring the possibilities that Google Cloud can offer. This session is meant as a quick overview to allow you to come from Amazon AWS platform to Google Cloud. If you find this content interesting and you want more, we have a course that expands on this, Google Cloud for AWS professionals. And we have other courses that delve even deeper into specific products within Google Cloud. Here at Google Cloud, we are always iterating and advancing our products and technologies. Depending on when you watch this, some of the interfaces may have changed slightly. But as always, our documentation at cloud.google.com is always up to date. In this session, I'll be providing you with a high-level overview of the Cloud Console, our interface into Google Cloud. Next, we're going to look at Google Compute Engine, where we can provision virtual machines for our workloads. I'll also look at our Cloud Marketplace, where we can find pre-configured solutions to utilize. Once we have a VM up and running, I'm going to explore cloud storage and see how we can retain both data and files within the cloud. We'll then move on to Google App Engine, our serverless solution for running applications. I'm also going to look at Google Kubernetes Engine, Google's managed Kubernetes service. And we're going to finish up with access management in Google Cloud. The main interface for Google Cloud is through the Cloud Console. This is acting as a hub for the majority of the work that we're going to do within Google Cloud. I'm going to explore this interface and explain where you can find most of our common products. Since we're going to cover a lot of topics today, I think a practical demonstration is the best way of seeing how each of these products work. So let's hop over to the Cloud Console now. Okay, and here we are in the Cloud Console. The Cloud Console is the primary web interface to Google Cloud. You can get to it by going to console.cloud.google.com. When you log in, you're presented with the screen we have in front of us. In the center point, we have our dashboard, which gives us an overview of the project we're currently working on. We can get project information here, such as our project name, ID, and number. We can see any resources we've provisioned. At the moment, this is an empty project, so nothing is existing yet. We can see how many API calls have been made. We can see our billing estimates for the month. Also, if we have any monitoring set up through our operations suite, we'll be given an overview either in this tag or in this tag here. Like with many dashboards, this is actually a customizable interface, so we can rearrange tiles to match the order we want. We can also remove tiles if they're no longer important to us. On the left-hand side, we have our burger menu, which can be toggled on and off by the burger menu up in the top left. This is our quick access menu that will bring us to the most common products within Google Cloud. So in the first section here, we have our kind of administration and marketplace. So our marketplace is an area to find pre-configured solutions, and we're going to look at that in a little bit. We also can set up our billing. We can look at APIs and then services that are available for our project. We can contact support. We can control access for our users through our IAM accounts. We can also look at elements like security, compliance, and migration using Anthos. But that's all a little bit beyond what we're going to cover today. The next section then is compute. Google's compute services are in a range of categories. The most common are Compute Engine, where we can provision virtual machines, Kubernetes engines, our container engine, and our serverless application solution, App Engine. We also have Cloud Function for event-driven calls, and we have Cloud Run and VMware Engine. But for today, we're going to look mainly at App Engine, Compute Engine, and Kubernetes Engine. The next section down is storage.
This is how we can store content in the cloud for our services to access. We're going to mainly look today at cloud storage, which is our bucket storage for Google Cloud. The next section down is databases. As you can see, Google Cloud offers many types of databases, both SQL and NoSQL format. Today we are going to mainly look at Cloud SQL and the different options that are provided there. The further sections we have are networking, where we can configure and customize our network for our Google Cloud infrastructure, as well as how does it connect to external resources. The operations suite for monitoring and logging of our infrastructure to be able to track and report on issues. And then we move into our tools. These are all beyond what we're going to cover today. However, we do provide training on all of these elements. In the top menu, we have, as I said, our burger menu up in the top left-hand corner. Then we have our project details. If we had more than one project, we would be able to switch between them here in this interface. We have our search menu. So rather than using the menu on the left-hand side, you can also search for what you're looking for here. You can also search for documentation. So if I was looking for documentation on Kubernetes, I can see that here I can quickly access documentation through the search bar here. And on the right-hand side, we have some account information, our notifications, and access to our Cloud Shell. So in addition to the UI interface that we've been looking at so far, Google Cloud also has access to a powerful CLI interface called Cloud Shell. Through Cloud Shell, you are able to do all of the tasks that we can do through the console, but in a CLI format. So if this is something that's more comfortable for you, or if you're developing programmatic creation of infrastructure, using the Cloud Shell may be a more natural fit for what you want to do. Let's shut this down for the moment. We're going to come back to this in some of our later examples. And let's look at our first demo, which will be Compute Engine. Let's get something up and running. The core element of your Google Cloud infrastructure is your virtual machine. Our virtual machines are hosted in Compute Engine. So let's have a look at setting a virtual machine up. To access my virtual machines, I've gone to the menu on the left and I've clicked into Compute Engine and VM instances. Because this is a new project, I have nothing to display here. As I provision new virtual machines, the list of the virtual machines and their information will appear in the center panel. So let's go and create instance. Let's change the name of our VM to my VM. We're not going to add any labels at the moment. We have the ability to choose our region and our zone. The choice of region can come down to usually one of three factors. The first factor is locality to your client base. It makes sense from a latency point of view to host your applications, to host your infrastructure close to the users who will be accessing it. So you can see if we click here, we have multiple regions split into three major territories: the Americas, Europe, and Asia Pacific. And within each of those regions, we have within each of those territories, we have multiple regions. Currently, I'm based in Dublin, Ireland, so the nearest region to me would be London. However, if I click on London, I notice that up in the right-hand side here, my cost is now currently $32.71 per month. If I were to revert back to my original, which was US Central 1, the cost drops down to $25.46. And this is the second reason why you may choose a different region for your virtual machines. If latency is not a priority or a factor within your infrastructure, cost may be. The location of your data center, where your infrastructure is hosted, will be reflected in the cost. So if we were to look at, for example, Hong Kong, we can see that we go up to $35. London was about $32 and Iowa was $25. So there is cost savings to be made by selecting a region that is more economical. Another reason why we may select a specific region is if you look in the machine family. In this machine family, I have several options here. I have general purpose, compute, memory optimized, and most importantly, the one that is the deciding factor is GPU. These are virtual machines that have GPU access to it. So here we have the NVIDIA A100 graphics cards. If I were to change my region to, let's say, London, I no longer have a GPU option. So if my application or if my infrastructure requires GPU processing power, well, then that may also restrict where I want to host my virtual machines. Each territory has regions which have GPU capable locations, but not every region, as you can see from the screen, has GPU currently. Let's return back to iOS Central 1. The next options here are our machine families. We have general purpose, compute optimized, memory optimized, and if available in the region, GPU. Within each of these, we have multiple options. So in general purpose, we can see that we can click on the machine type, and we can see that we have some predefined configurations here. In standard, shared core, which would be very small VMs, high memory, and high CPU. We also have a custom option where if I click on this, I can now move my slider up and down to specify how much CPU and how much RAM or memory access this virtual machine should have. Let's return back to our standard E2 there. Compute optimized and memory optimized give us other options with a priority towards either compute or memory heavy machines. So you can see here we've got compute optimized, so we can go up to 60 virtual CPUs. And with memory optimized, we can have a look at a 96 CPU with 1.4 terabytes of RAM memory, which is a gargantuan machine based off of on-prem requirements. So we can see that the elasticity of the cloud is to our benefit at the moment here. So let's return this back just to a standard machine to keep our costs reasonable. So you can see here, this is $49 per month for a 2 CPU, 8 gigabyte memory machine. We can also look here to see our boot disk. Now at the moment, our boot disk is creating a 10 gigabyte Debian Linux boot disk, but if that wasn't what I wanted, I can click on change here. And I have the option of selecting my operating system, several Linux variants, plus Windows Server and SQL Server on Windows Server. So we have options for both Linux and Windows here, but I'm going to leave it as Debian. We also have the choice of our boot disk. So we can have balanced, we can have SSD, or we can have standard. Standard persistent disk is our normal spinning drive disk. Let's leave it at balanced because that's our most economical option. And let's leave it at 10 gigabytes. We'll click select there. We then create our service account, and this is our default options here. We can allow for HTTP and HTTPS options. If we click into our management, security, networking, and sole tenancy drop down, we can see here that we can add in information for a startup script. So we can put our startup script within here. So it proactively does that as the machine will provision. It will run that startup script for us. We can classify this machine as preemptible. So if your virtual machine is preemptible, essentially you're allowing Compute Engine to reclaim those resources within the first 24-hour period of it running. This is ideal for workloads that don't require consistent, uninterrupted processing time. After a maximum of 24 hours, if Compute Engine hasn't reclaimed the resources, the virtual machine will be shut down. Now, why would you do this? Well, preemptibility is absolutely a way of economizing the cost of your infrastructure. If you can run a small batch job, which wouldn't take more than 24 hours and has the ability to be terminated mid-workload and then restarted, preemptibility may be a very cost-effective way of actually setting up your infrastructure, but for the moment, I'm going to leave that off. We can also set up some of our network options, so we can have a look at our security and see what security options we want to implement here. We can look at our disks and see if we want to have additional disks added in, or if we want to have our encryption keys to be managed by Google, managed by ourselves, or to be supplied by the client themselves. We can define network parameters here, and we can also define our sole tenancy. to allow for a single application, a single use per virtual machine, so we're not sharing it with anyone else. But we're going to leave all these options as standard. Now I'm creating this through the UI, but if I wanted to create it through Command Shell, and I wasn't sure of all of the commands, by clicking the, let me close it down for a moment, by clicking this command line option down here, I can see what the command shell is. Now this is a very verbose command defining all of the information that we would require, probably more so than you would absolutely need to. I'll show you in a moment, there's a quicker way of defining this content where it just accepts a lot of the defaults, and so it's not as verbose as this command here, but we could run this in Cloud Shell if we wish. So what I'm going to do here is I am going to provision that VM. Google Cloud virtual machines take approximately 30 seconds to spin up. Obviously, depending on the complexity of the machine, this could increase the time, but a standard virtual machine spins up reasonably quickly. While we're waiting for that to spin up fully, I'm going to open up our Cloud Shell and let's look at how we can provision our virtual machine through the CLI. So as I stated in our first demo, the Cloud Shell is our command line interface to Google Cloud. So we have this wonderful UI here in front of us, but we also have access to a more CLI focused, which depending on your background may be far more your preference to actually interact with the cloud base. Okay, so let's go and create a virtual machine through the CLI of Cloud Shell. The first thing I want to do is I want to run a gcloud command that will list out all of the zones that are available at the moment. And I'm going to restrict that by everything in US Central 1. So what this will do, right, typo complete. What this is going to do, I need to authorize that command call. Let me actually increase the font size here while we're working. So what this command does is it will list out within US Central 1 all of the zones and their current status, whether they're up or down. So as we can see from the interface here, my initial virtual machine was in zone A. So I'm going to configure the next VM I'm going to create in a different zone. I'm going to put it into zone B. So here what I'm going to do is I'm going to do another gcloud command, and I'm going to basically configure the compute zone to be US Central 1B. And now that's set as a default parameter. So when I run the next command, I don't need to define the zone because it's already been defined for us. So the command to actually run our virtual machine or to create our virtual machine is again another gcloud command. So gcloud compute, because that's the pillar that I'm working within. I'm going to deal with instances. And what I want to do with the instances is I want to create one. So the next thing we need to do is we need to define a name. So I'm going to call the name of my VM to be a highly original myVM-2. I'm going to say the machine type is going to be N1 standard 1. So that's going to be something slightly different to what we have here. This is an N1 standard 2. So here we only have one CPU. I'm going to use a specific image. So my image for my project is going to be Debian Cloud. My image family is also going to be Debian 10. I don't need the equals there. So and the subnet I'm going to put it into will just be the default subnet. Okay, so when I run this command, it is going to provision a new virtual machine for me. The virtual machine will be called myVM2. It'll be of type N1 standard 1. It will take the image from Debian Cloud, which is of a Debian 10 family, and it leaves it in N1 standard. So you can see here, it was a pretty fast spin up. I have all my information. It's set in US Central 1B because I've defined that in the previous command. And if I refresh this page here, both virtual machines are available here. Both of them have external IP addresses. But since I've enabled HTTPS and HTTP access, this one here has a link where I can actually click on it. This one doesn't have external access yet, but I could go in and I could amend that if I wish. The last thing I want to do is I want to access my virtual machine. So these are Linux virtual machines, so I'm going to SSH into them, which will open up a new window. I'll take a moment to connect. And now that I have access here, I'm just going to run a simple sudo apt-get. And I'm going to install Nginx, the old reliable. I'm going to install the light version. And that will go off and it will retrieve all of the source it needs and it will install it into my machine. Okay, let's return back to our console. So in our console here, we can see we've created two virtual machines. One we created using the console UI itself, and VM2 we created using our Cloud Shell. And we have the ability to interact with both of them either via the console or via the Cloud Shell. I'm sure you noticed in that last demo that Amazon EC2 and Google Cloud Virtual Machines have a lot in common. This makes a lot of sense. They both aim to replicate an on-premise machine. Both Compute Engine and EC2 allow you to choose and configure the RAM, the CPU, and the GPU of your machine. Both offer a wide range of operating systems. Additional disks can be added to both types of virtual machines. Ephemeral and static public and private IP addresses can be used for both types of instances. And both instances can use metadata and scripts for bootstrapping. But there are some differences between EC2 and Compute Engine. First is the spin-up time. Typically it takes about 30 seconds for a Compute Engine instance to start. An Amazon EC2 instance can take minutes. Google Cloud and AWS both offer block storage options as part of their compute services. Compute Engine provides persistent disks, and Amazon EC2 provides Elastic Block Storage, or EBS. Each service has several block storage types that cover a range of price and performance characteristics. Regional persistent disks provide durable storage and replication of data between two zones in the same region. If you're designing robust systems and Compute Engine, consider using regional persistent disks to maintain high availability for resources across multiple zones. AWS does not offer a regional persistent disk option. Amazon EC2 offers temporary instances called spot instances. And Compute Engine offers similar instances called preemptible VMs. Both provide similar functionalities, but have different pricing models. With Compute Engine, VM pricing is fixed, although depending on the machine type, preemptible VM prices can be discounted nearly 80% of the on-demand rate. If not reclaimed by Compute Engine, a preemptible VM runs for a maximum of 24 hours and then is automatically terminated. Also, if you're using a premium operating system with a license fee, you will be charged the full cost of the license while using the premium VM. Compute Engine and Amazon EC2 have similar on-demand pricing models for running instances. Both charge by the second with a minimum charge of 1 minute. In Amazon EC2, discount pricing can be obtained by committing to provision reserve instances for 1 or 3 years. The more you pay up front, the greater the discount you get, subject to conditions. For Compute Engine, discounted pricing is obtained through sustained use, and the discount is automatically applied. The longer you use an instance in a given month, the greater the discount, with potential savings as much as 30% on the standard on-demand rate. Although AWS has an extensive list of Amazon Machine Images, or AMI options, you have to select a predefined instance to use. Google Cloud allows you to build a custom machine to your exact specification. So we've just seen how we can provision virtual machines both from Cloud Console and from Cloud Shell. But we do have a third option available to us. Google Cloud has the Cloud Marketplace, which can be found over here, our top link up in our menu on the left-hand side. The Marketplace is a great resource for finding pre-configured solutions across a range of functionality and capabilities, in addition to other elements like APIs, datasets, and other resources. So what we want to look for here is we're going to provision a very simple web server onto our infrastructure. So we're going to search for LAMP. So our Linux, Apache, MySQL, PHP stack. And you can see here that we have multiple options. It doesn't really matter which one we pick. The reason why we have multiple options is different vendors will actually create their own version of a solution. So we have a choice to choose from. We're going to pick here LAMP certified by Bitnami. What we're going to be presented with is an overview of the product that we've picked. So we can see on the right hand side here, it's got to run on Compute Engine. So all of these marketplace solutions, they are essentially saving you the time of provisioning a VM and then installing all of that required software. It's done for you, and it's a very fast deployment. So we can see here it's going to be a Compute Engine virtual machine. Here's the detail of all the package that it has inside it. It's going to be running on top of Debian 10, which is very similar to our prior virtual machine. We can see here that our usage breakdown is we have one VM instance with quite a small machine, plus our persistent disk. We're getting a bit of a discount for sustained usage. So that's assuming that we're going to use it for a specific amount of time. And so it works out at about $5.13 per month. So if I'm happy with all of those, I can click onto launch. And here I'm given a little more details before it actually creates the virtual machine for me. So I can choose the name. I'm happy to leave it as LAMP Stack 1 for the moment. I can choose the zone. I can choose what type of boot disk I have. So standard, SSD, balanced. I can choose the size of my boot disk. I can also configure the network options for me. And I can change the machine type. So if I decide that, well, do you know what? This solution has everything I want, but I need a more powerful machine or a machine with greater memory, I can configure that here. I'm not going to edit any of these details. What I am going to do is I'm going to select that I accept the terms and conditions of the marketplace, and I am going to deploy. And so this will create a third virtual machine within our infrastructure. And this virtual machine will have all of the elements we need for our LAMP stack to be installed. So what's happening at the moment is Deployment Manager is running through the script that we have to create this instance, to configure this instance, and it will give us the relevant information here on the right-hand side once that's done. So you can see here, you can see the progress as it's moving toward it, what firewall rules have been set up, what configuration files for the software has been set up. So we have visited all of that content. So if I were to click on this URL here, it will bring me to a new page where it gives me my Bitnami LAMP. So I can see that all of that content is up and running. So that is our very quick deployment from our marketplace. Now, if I were to go back to our main page and I were to go to Compute Engine and our virtual machine instances, we can see that our LAMP stack is here. We can see some information about it. We can see it's in USC Central 1. It has its external IP. It has its internal IP. We can also SSH into it. So it's a fully functional virtual machine that has saved us actually having to either write a startup script or to SSH into that VM once it's provisioned to configure all of that software for us. So the marketplace can be very useful in finding pre-configured solutions for your infrastructure. So we now have some virtual machine instances provisioned. So we can see here, we click into our Compute Engine. We have our 2 VMs that we created ourselves and the 1 VM that we created from our marketplace. What we want to do now, the next logical thing to look at is how do we store data? So what we want to do is we want to have a look at creating our cloud storage. And if I go here, I'll see that I've got no buckets created. So what I'm actually going to do is I'm going to create our bucket through the command line. I could use the UI here, but let's use the Cloud Shell. Okay, the first thing I want to do is I want to create a variable called location. And I'm going to set that value equal to EU. So this is going to be reflective of where my content or where I want my bucket to be created. And I can check that by by echoing out my location. I can see EUs there, so that's perfect. The next thing I want to do is I want to run a gsutil command. So gsutil is our command line operator for creating or for managing Google Storage. GS Google Storage util. So it'll be gs, not in caps lock, gs util. And then we need to give the rest of our commands. So it's going to be mb for make bucket. We're going to define our location, so where we want the bucket to be, which will be our location variable. And now I want to define the name of my bucket. So GS for Google Storage. And I'm going to use a special variable here, which is our dev shell project. So the key with Google Storage is we need a globally unique identifier for the bucket. And if I just make up a bucket name, there's no guarantee that someone else hasn't. This isn't just project specific, it's actually Google Storage specific. So you can see up at the top here, if you remember the information on our project. So that's my current project that I'm in. So this, when I use this command here, dev shell project ID, it's essentially going to give me this value, which is guaranteed to be globally unique. And it's going to make an API call. So yes, I want to authorize that. And it's going to create the bucket for me. So now if I refresh my console, I will see that I have a bucket here and it's based inside EU. And it has public access, basic, subject to the object ACL. So it has fine-grained access control. Now that I have my bucket, I want to put some data in it. I'm going to put an image in it. And then what we're going to do is we're going to display that image on our LAMP stack that we deployed from our marketplace. So I'm going to quickly just paste in the command to pull down the image there. And so you can see this is going to, again, it's GSUT. It's going to copy from an existing storage place to to a file called myexcellentblog.png. At the moment, this is not in my cloud storage. If I went and had a look at storage here, there's nothing in here yet. What I've done is I've pulled it down from a different storage bucket to my local hard drive storage for this cloud shell, which we are provisioned with about 5 gigabytes per project. What I need to do now is I need to do a gsutil command. Ooh, that's not what I wanted. Storage. What I need to do now is a gsutil command that I want to copy my excellent blog PNG, and I want to copy it to my dev shell project ID. Bucket. But it's not enough just to copy it to the bucket. I also need to give it a file name. So let's call it the exact same there. So an excellent blog PNG. Okay, and now it's created. So if I go into my bucket now, this bucket that we've created, we will see that we have an image in here. It's not public yet, which we'll address in a moment. And if I open up here, we'll see a more summary of it. So here's the actual image itself, very basic. Here's my authenticated URL. So if I'm within Google Cloud Project, this is how I'd access it. Here's my gsutil URI for it. But what I really want is I want the publicly accessible, because if we're serving a website and I have all of my data stored in cloud storage, I want this to be available to the public. So how I'm going to do that, I could do it in two ways. One, I could go edit permissions up here. Actually, let's do this. Let's have a combination. So edit permissions, I'm going to go add entry. I'm going to say public. And it's saying that all for a public permission, it applies to any user. So not just people who are validated inside this project, and they only ever have read access. And if I go save, what will happen now is all of a sudden I have this public storage here. So we're pretty close. What I want to do is I want to now SSH into my LAMP stack, and I want to create a very simple web page that will pull this
site here. So let's go back to our virtual machines because I need to SSH in. I'm going to SSH, which will open up a new window. I need to navigate to my web document folder. NAMI / Apache 2 / htdocs. Oh, because I forgot the bracket at start /start. Okay, so now if I have a look here, I have a simple file there which is called index.html, but I'm going to create a PHP file to make this a little bit easier for the next stuff I want to do when we look at SQL. So I'm going to say sudo nano index PHP. If you haven't used nano before, so sudo is our super user command. That's just going to make sure that we have administrative access to this file. Nano is a text editor we're going to look at, and PHP or index.php is the file we want to use. As you can see from up here, we don't actually have that file created. So if the file doesn't exist, it's going to create the file for us. And it's going to present us with a blank page. And I'm just going to paste in some stock HTML to get a very basic web page up, and then we're going to add content to it. Okay, so I'm just going to paste in now. And then we need to close off the body and close off the HTML. So a very, very basic website. Literally, it has a title and it has one heading. So let's save this. So we're going to go Control X to save. It's going to ask us, do we want to keep the same file name? Yes, we do. And confirm it. I'm going to leave the SSH window open because I'm going to go back here to my VM instances. I'm going to click on my VM stack, and it should bring me to the starting page. Yes, I want to keep going with this one here. It brings me to the starting page for Bitnami. And if I change that URL now to /index.php, I should see the file I wrote, which is exactly what I wrote there. It's a web page that literally just has my welcome to my excellent blog in there, which is exactly what I wrote inside here. So now I want to add some extra content. So I'm going to create an image, and I need the URL of that image. So let's go back to my Cloud Shell. Let's go down to storage. Let's go to browser. Let's go into my bucket. And here I just want that. So I'm going to go copy URL. I'm going to go back to my Nano page. I'm going to paste in my URL here. And I'm going to close off that tag. And I'm going to save my file with Control X again. Yes, I want to keep the same file name. Okay, so now we've updated our image. If I go back to my web link here, so this is where we were, the index.php. If I refresh this, I now see that my image has been pulled from cloud storage and it's inside our web page. For standard distributed object storage requirements, the main difference between Cloud Storage Standard and Amazon S3 Standard lies in the deployment locality. Where S3 Standard is regional, Cloud Storage is multi-regional and regional. Cloud Storage and Amazon S3 each offer a reduced cost class for data that does not require the availability of standard storage tier. Cloud Storage offers Cloud Storage Nearline, and Amazon S3 offers standard infrequent access and one zone infrequent access. Again, the key here lies in the deployment locality. While Cloud Storage Nearline is multi-regional and regional, S3 Standard IA, or infrequent access, is regional, and S3 One Zone IA is zonal. Google and Amazon each offer cold storage options for data that does not need to be accessed regularly or retrieved quickly. Cloud Storage offers an additional class called Cloud Storage Coldline, and Amazon offers Amazon Glacier. In addition to the deployment locality difference again, a key difference is that first byte latency. For Cloud Storage Coldline, it's milliseconds, which is the same as for Cloud Storage Standard. The latency for Amazon Glacier can range from minutes to hours. So we've just created a storage bucket. We have added an image into it, and we have accessed that image through our website here. But let's go a step further. Sometimes it's not just files we want to access data. So let's create a database. So if I go to my menu on the left, I'm going to scroll down past storage, down to databases. And what I'm interested in here is the SQL. I'm going to create an instance because I haven't created one yet. I actually don't need my Cloud Shell, so I'm going to close that down. I'm going to create a MySQL instance, but you can see also we have PostgreSQL and SQL Server, depending on what your preference is, but I'm going to choose MySQL. I'm going to give it a simple title here called BlogDB. I'm going to give it an incredibly simple password, which is just going to be password. Obviously, I wouldn't recommend you use the simplest password as this, but it'll do for me. I am going to choose single zone because I want a cheap and quick option to spin up. I'm going to go down to my configuration. I'm going to go down to create instance, and I'm going to leave all the other options as default and hit create instance. And this will create my SQL Server. Not my SQL Server. It'll create my MySQL database. And this will take a couple of minutes to spin up. So through the magic of pre-recorded demos, we will pop back when it is done. Okay, so our database is now spun up. Before I start adding in any users or any connections, I need to very quickly just go back to my compute instances. And I need to get the IP address, the external IP address of my LAMP stack for authorization. So I'm just going to copy that for a moment because this is the one that I want to be able to authorize into my MySQL database. So let's go back to our databases and into BlogDB. So there's a couple of things I want to do. The first thing I'm going to do is I'm going to create a user. And I'm going to add user. I'm going to give it a name. I'm going to call this one here BlogDB user. And I'm going to set, again, a ridiculously silly password of the word password, all lowercase. And I'm just going to click add. Okay, so this is creating my user for my account. The next thing I want to do is I want to go across to connections. And I'm going to create a new connection here. So I'm going to click on add network. And I'm going to give this the name of web frontend, just so I know where the data is coming from. And I'm going to paste in that URL of my LAMP stack. And I'm going to go /32 to make sure that it allows in all connections from this IP address. So I'm going to click done and I'm going to click save. And now our database, once this refreshes, is ready to go. I have created a user, so I'm not using my root user, which is really poor protocol for your database. And I've created a connection that will allow queries coming from my LAMP stack. I haven't bothered creating a database because that's beyond the scope of what Google Cloud manages. That's your responsibility as the cloud administrator. But once this is spun up, we are going to then go back to our SSH terminal for our excellent blog. So there's the actual blogs at the moment. Remember from our last example, we just had the image in there. And I'm going to go to my SSH and I'm going to open this back up again. And it presents me with the image I'm used to. And what I'm going to do is just below the image, I'm actually going to insert a little bit of template text here. Okay, so what we have is we have the IP address of our cloud. So I need to actually put that in. So it is 35.903.105.43. If for some reason we couldn't remember it, we could go back to our overview here and click on the overview. And we would see that that is listed here. Let's go back to our SSH. We have our user being BlogDB user, that's fine. Our password, I'm going to update to the password I used, which is just password. Oh, that wasn't working. Hang on a moment. To password. So the skeleton text here is going to send off our connection string. And if we get a connection error, it's going to tell us that we've failed to connect to the database. Well, that makes sense. And if we don't get a connection error, it's going to say we've succeeded. And that's all we want to do. We just want to prove that we can actually connect. So we're going to go Control X to save, Y to confirm. Yes, we're saving the same file name, and correct. So assuming I have no more typos, when I refresh this page, we should see at the bottom, database connection succeeded. So now we've connected to our SQL database inside Cloud here. And if I were to go back in and edit this one more time, just for illustration, and just change that password just a little bit, just to show that authentication is working. So just to get rid of the A there, and we're going to save that. And Y, I'll go back here. We can see now that we're getting database connection failed and we were access denied. So we had the right username and we had the right address. However, we had the incorrect password, and that's where we're getting our connection failed. And so that's our database options that are available within Cloud SQL. Again, I hope you notice the similarities between Amazon Relational Data Service, or ODS, and Cloud SQL. Both are managed relational database services that use commercial relational database management systems. AWS and Google Cloud will manage the infrastructure of the databases to include the instances, the backups, the updates, and failover. The user is still responsible for data management, schema construction, and user management. Reads and writes can be scaled differently. For the write database, the instance can only be vertically scaled. You can make a single write database larger. You can horizontally scale reads with read replicas and put them in different zones or availability zones. A failover replica can be built in another zone or availability zone. The cloud provider is responsible for the failover process. Let's compare Cloud SQL and Amazon RDS. In Amazon RDS, you can use VPC security groups to authorize connections, or use RDS security groups to give database users and groups access to tables, views, and queries. In Cloud SQL, you can use VPC firewalls, or Cloud SQL proxy, or authorize networks by adding IP addresses to an allow list. Both Amazon RDS and Cloud SQL support the use of SSL for encrypted external connections. You can also use Cloud SQL proxy to encrypt connections to Cloud SQL databases. In Amazon RDS, you can enable encryption of data at rest. In Cloud SQL, customer data is encrypted by default when on Google's internal network and when it's stored in database tables, temporary files, and backups. You can create a read replica in Amazon RDS. In Cloud SQL, from MySQL, you can create a read replica of an SQL instance. You can also create an external instance that replicates from a Cloud SQL primary and create a replica in Cloud SQL from an external primary instance. In Amazon RDS, backups are enabled by default. In Cloud SQL, you can optionally enable automatic backups. Okay, let's look at App Engine. App Engine is Google's serverless application platform. It allows you to create an application without the need for worrying about server management, auto-scaling, or load balancing. Apps in App Engine will automatically scale to the demand that's been requested from them. There's a variety of runtimes we can use. And we can even use custom runtimes if we have third-party libraries or proprietary software we're using. So let's create a mini app in App Engine. So I've opened up Cloud Shell. I'm in App Engine here on the console, but that's more just to show the progress that's happening with my app. So I'm in Cloud Shell. I'm going to run a couple of commands first. So I'm going to run my gcloud auth list and gcloud config. No, I should probably type in this. List project. And these are just to get my account set up and ready to go. Okay, so that's done. The first thing I want to do is I actually want to create an application. So to create an application, I'm going to use gcloud app command. Okay, so we're working within gcloud here. We want to use App Engine, so app is the subset we're using. And what do we want to do with App Engine? Well, we want to create something. So as you might imagine, the next part is create. And we also need to put this app into a project. So we need to define which project we're putting it in. And I'm going to use my dev shell command from the previous demo just to make sure that we're putting it into this project's project ID. And that will go ahead. And what's going to happen now is it's going to ask, where do you want this based? We get a list of all of the regions that are available to us. I'm going to pick region 9, which is Europe West 1, because it's just the closest one to me. And this will take a moment to actually spin up, and we'll check back once it's ready to go. Okay, so our app is now fully deployed. And if I refresh our console screen, we should see that yes, we have an App Engine application has been created. But this is essentially just a skeleton. There's nothing inside our App Engine yet. So what we want to do is we want to create a local application, test our local application, and then deploy that out to our App Engine. So what I want to do is I want to download some sample code for a Python application and get all the tools I need set up on this machine. So let's go ahead and do that. Okay, so first thing is, let's get our Git sample. Close this down out of the way. It's larger. And this is going to download our application. And then we're going to navigate to our folder that we need to navigate to. Which is our Hello World app. Now that we're in the right location, I need to do a couple of things. I need to make sure that I have the correct environment to actually be able to run this code locally. So I'm going to do a couple of quick commands just to get ourselves up and running. I'm going to do a sudo apt-get update. And this will run for a moment, so we'll check back in a second. Now that that's complete, I need to install a piece of software. So I'm going to do sudo apt-get install, and I'm going to install my virtual environment so that I can actually run my Python application. And again, this will run for a second and we'll check back once it's done. Okay, so now we've installed our application. I need to set up our virtual environment very quickly for Python. These steps that I'm doing at the moment are only necessary because I'm running everything from my Google Cloud environment. If I had a dev machine already configured for Python development, this would not be an issue. We wouldn't have to do any of these steps. But let's get through this. Okay, so we're almost there. I need to set up our source now. Okay, now the last thing I need to do is just run a pip install. And this is our last step. So the last thing we need to do now is actually just run the application, just to verify it's working before we go and try to deploy it to App Engine. Okay, so my app is running and it is running on localhost here. So what I'm going to do is to verify that, I'm going to go up and go preview on port 8080. This should open up another tab and it'll show me Hello World. So we know that that's now running locally. So we can quit out of this by doing Control-C. What we want to do now is we want to actually deploy this to our App Engine. So I need to navigate to the correct folder. And now that I'm in the correct folder, I'm going to run the gcloud app deploy environment. And this is going to, first of all, it's going to highlight what I want to run. So it's going to run from this source folder here. The definition is in this app.yaml file. So the app.yaml file, I'll open up in a moment, but the app.yaml file defines how my application is going to be created for App Engine. And for our application, since it's Python, we can run this in standard environment. So it'll probably say environment with standard and the runtime being Python. And everything else is essentially just local to this project. This is a project we're running it on, which will match my ID project up here. We're leaving the target service as default. Target version is this, which just matches my timestamp and time date stamp for today. And the URL, once this is live, is here. Now it's worth noting this is AppSpot, and this tab up here is cloudshell.dev. So they are two different URLs. One is my local machine, the localhost version for my local machine, and what we're doing now is we're uploading it to the AppSpot, which is our App Engine portal. So this just needs to upload. I'll check back in a second. Okay, so we have now deployed our application to App Engine. If I were to refresh this now of the console, I no longer see the introductory screen. I now see information for specifically the app that we have running here, which gives me information on my account, when it was created. You can see there's more information here loading up, the type of operations, the current load, and so on. So we do get kind of our dashboard here once the app has been created. Before I have a look at the app just to verify it works, or actually, let's do that first. Let's go gcloud app browse. And what this will do is this is going to tell me the URL specifically I need to go to, which is this one here. And if I click on it, we can see that we get Hello World again. So it's the same application. This is quicklabs-gcp. So this is matching my project name here, .eu or ew.or.appspot.com. And if I have a look on my other tab, which is my local version, I can see here that this is Europe West 1, CTGQ, cloudshell.dev. So they are definitely two different URLs we're pulling the same application from. This one here in the local one, and this one here in the App Engine version. Before we finish up, I just want to return to the app.yaml. So if I list the files that I have in this folder here, if I have a look at app.yaml, we will see that this gives me my definition of what we need. And so all we have to define here is that the runtime is Python 3.9. We don't need to define that it's the standard environment because that's the default. If it was the flexible environment, so if we had a custom runtime or a runtime that is not supported within standard, we would need to have another example here of environment flex. But for this example, we don't. Quit out of that. Okay, so that's App Engine. App Engine Standard, App Engine Flexible, and AWS Elastic Beanstalk offer similar PaaS functionalities. All three can use autoscaling as a way of leveraging the resources as needed. All three can also be secured using IAM roles and are available in the US, Europe, Middle East, Africa, and Asia Pacific territories. Let's have a look at how certain features differ between the two App Engine environments as well as Elastic Beanstalk. App Engine and Elastic Beanstalk both support a variety of runtimes. App Engine Standard supports fewer runtimes due to the lockdown environment that Standard supports. App Engine Flexible and Elastic Beanstalk both support custom runtimes. App Engine Standard comes with a free tier. Elastic Beanstalk has a free tier for the first year. After the first year, the free tier is no longer available. App Engine Standard doesn't support network controls. Only IP endpoints are exposed to the internet. App Engine Flexible and Elastic Beanstalk both support the use of VPCs. For application authentication, Elastic Beanstalk requires you to write the authentication into the application running on the platform. For App Engine, Google offers a variety of identity providers using Firebase. All three options support the use of task and message queues. For Google Cloud Services, App Engine can use Cloud Task API or Cloud PubSub, which is a push-pull managed message queue. Elastic Beanstalk uses Amazon Simple Queue Service only, which is a pull queue. Pricing for App Engine Standard is based on instances per hour with a free tier. App Engine Flexible is based on virtual CPU cores per hour, memory per gigabyte hour, and persistent disk per gigabyte per month. Elastic Beanstalk pricing is based on the underlying AWS services used. And our last demo for today is Google Kubernetes Engine. So we've seen Compute Engine, where we can provision virtual machines and we control them 100%. We really can have almost a replication of what we have in an on-prem scenario. And we've seen App Engine, where we can have our serverless management of our applications. But what if we need our container system? Well, hypothetically, we could create a virtual machine and we could install Docker on it and host everything from that. But Google actually has a managed service called Kubernetes Engines, which allows us to create Kubernetes clusters from Docker containers that, as with App Engine, Google will help the running of those, both with the scaling and with the health monitoring. And it takes pressure off you as the user in actually trying to maintain your Docker server. Just like with App Engine, we could do this through the UI, but I'm going to do it through Cloud Shell just to kind of illustrate, again, the process we do. With the UI, it's pretty self-explanatory, so let's go through the Cloud Shell command so we can see it. The first thing I want to do is I want to create a variable called myZone and set that equal to US Central 1. So I'm just defining 1A. I'm just defining where I want my cluster created. Okay, now that I've done that, I'm actually going to create a cluster first. So creating the cluster will actually instantiate the Kubernetes cluster for us. And then once that has been done, we can actually deploy workloads to that cluster. So the first step is creating the cluster. So gcloud container. So we've seen so far gcloud instances when we're dealing with VMs and Compute Engine. We've seen gcloud app when we're dealing with App Engine. Now we're looking at gcloud container when we're dealing with our container engine, or what we call Kubernetes engine. And we're dealing with clusters, and what we want to do is we want to create them. And I'm going to call my application web front end. And the zone is going to be equal to, as you might have guessed, myZone. And this is going to create a cluster for us. That will take a couple of minutes. So we will pop back up when this is spun up fully. Okay, so our cluster has spun up. If I were to refresh our cluster console page, you can see that we have our web front end here. It's got a number of the nodes is 3, which is a total of 6 CPUs and a total of 12 gigabytes of memory. And we're based in US Central 1A. We can also, from our console, from our Cloud Shell, verify which version of kubectl we have installed. Which is telling us that we have 1.8. Sorry, the client version is 1.20 and our GKE version here is 1.8.16. Great. Okay, so now that I have a cluster, and inside that cluster I have several pods that have been created, or several nodes that have been created, I actually want to deploy a workload to it. So what I'm going to do here is I'm going to do kubectl. I want to deploy something, so I'm going to create a deployment. And I'm going to create our old reliable of Nginx. And the image I want to use is the Google image we have, which is Nginx. And the version is 1.17.10. And now it has created that deployment from my application. So if I were to check to see what pods are running, I can see that I have my Nginx deployment there, 1 of 1, and it's running, and it's about 11 seconds old. So that's a decent amount of information. The issue here is that while I've created a web server, I haven't actually made it viewable from the internet. So I need to expose this Nginx container to my internet.
And the way I'm going to do that, again, is another kubectl command. So kubectl expose the deployment, which is my nginx deployment. And I want to expose port 80. And I want this type to be a load balancer. Okay, if we think about why Kubernetes is such a useful resource, the balancing of workloads to make sure that it's distributed across each of the nodes within our cluster is one of the key elements. So what this command is going to do is it's going to create a new service, and it's going to add an external load balancer to that service with a public IP address, which means that that's where the public will access our application. And the service itself, the load balancer, will decide which node has the free capacity to actually accept in any inquests. So we can verify this by having a look at our kubectl services. And it would help if I did the command correctly. So sorry, I left out the word get services. And so as we retrieve back, so we've got our Kubernetes here where we have no external IP. Okay, and this is about 5 minutes old. And then we have our actual nginx load balancer, which will have a external IP in a moment. And that's how we're going to be able to get access to our application. So you can see now that we have a external IP. If I copy that, and if I open up a new tab, I'm now getting to my nginx page directly. I can't go directly through my cluster because I don't actually have an external IP there, so it's not possible to access it. The next thing that I want to have a look at is I can see from here that I've got 3 nodes. Perhaps I actually realize that we're going to need more than that. Okay, so what I can do is I can run a command to scale up my cluster. So kubectl. I want to scale my deployment, which is my nginx application. And I want to define that I've got 5 replicas rather than 3. Okay, so my nginx deployment has been scaled. And if I now run get pods again, I can see that I have 5 versions of this running. The first one was running for about 3 minutes because that's the first one we did, and the one we've just scaled up, or the 4 that we've just scaled up, exist here. And I can also then verify that I still have get services, and my IP address here is still the same as before I had scaled my application. So it's important that once you have your load balancer, you're aware that no matter if you scale up to 100 or 1,000 replicas of this deployment or back down to 1 replica of this deployment, the load balancer is the input point, is the ingress point. So all traffic is going to come through that IP address, and then internally it'll be distributed to the appropriate node. And that's an example of our Kubernetes engine in Google Cloud. There's plenty more that I could talk about, but it's a little bit beyond this today's session. Both container systems use a cluster of virtual machines to run and manage their containers. GKE uses compute engine instances, while Amazon EKS and Amazon ECS uses EC2 instances. While Amazon ECS supports Docker, GKE and Amazon EKS support both Docker and Rocket format containers. The node agent for GKE and for Amazon EKS is the kubelet, which is an open source agent used with Kubernetes. Amazon ECS uses a proprietary Amazon ECS agent. GKE and Amazon EKS both group containers by pods, which is how Kubernetes runs applications.
Amazon ECS uses a specific group called a task. Sizing can be done on GKE using a replication controller, while Amazon EKS and Amazon ECS use a service. Running a command on GKE can be done through a combination of the open source kubectl command and gcloud. Amazon EKS can use its own CLI or kubectl, and Amazon ECS uses the Amazon ECS CLI. Finally, one of the big advantages of GKE is portability. Kubernetes can run on a variety of clouds as well as physical hardware and virtual machines. Amazon EKS and Amazon ECS can only run on AWS. IAM for Google Cloud and AWS perform the same function, to provide a mechanism to secure user authentication and permissions for the cloud. IAM does not secure applications or operating systems. IAM is used to control who can do what in the cloud. Although IAM for Google and AWS perform the same function, they do it in very different ways. Google uses service accounts to control service-to-service authentication. AWS uses IAM roles and profiles to accomplish this control. For Google Cloud, user identities are managed outside of Google Cloud. For example, Workspace or Gmail accounts can be used to manage identities. For AWS, user and group identities are created using AWS. For EC2, instance profiles can also be used. For Google Cloud, policies are a list of bindings that set a user's permission by the role applied. Policy documents are used by AWS to apply permissions to users. The document is built using JSON and is applied on the resource. User role pairings on a resource determine a user's permissions in Google Cloud. In AWS, predefined permissions can be applied using managed policies, which are pre-built JSON documents used to apply default permissions. Google uses predefined roles, which are built to match job roles. AWS has something similar called managed policies. Managed policies are JSON documents that group permissions by job roles. That concludes today's session. Moving cloud provider is a big undertaking with many possible pitfalls, but hopefully through the demonstrations and explanations that I've covered today, I've shown you some of the potential that Google Cloud can offer. I hope you'll be able to bring your applications and systems to Google Cloud, and you'll be able to do so with confidence based on the training that is available from Google Cloud. Thank you for tuning in. Please visit cloudonair.google.com for more hands-on learning, training, and demos from Google Cloud experts. See you next time. Hello, and welcome to Cloud on Air Live webinars from Google Cloud. My name is Owen Carroll, and I'm an infrastructure technical curriculum developer here at Google Cloud. You're watching a hands-on session to introduce Google Cloud to Azure professionals. Over the next hour, we're going to look at Google Cloud and the services that we offer. We're going to go through a couple of demos of our products to get you familiar with their basic functionality, and with any luck, link them back to products that you are familiar with in Azure. Our goal is to bring you through the interface of Google Cloud and get you comfortable with the basic elements. We hope that by the end of this session, you will feel confident in exploring the possibilities that Google Cloud can offer. This session is meant as a quick overview to allow you to come from the Microsoft Azure platform into Google Cloud. If you find this content interesting and you want more, we have a course that expands on this, Google Cloud for Azure Professionals. And we have courses that delve even deeper into specific products within Google Cloud. Here at Google Cloud, we are always iterating and advancing our products and technologies. Depending on when you view the session, some of the interfaces may have changed slightly, but as always, our documentation at cloud.google.com is always up to date. In this session, I will start by providing you with a high-level overview of the Cloud Console, our interface into Google Cloud. Next, I'll look at Google Compute Engine, where we can provision virtual machines for our workloads. I'll also look at Cloud Marketplace, where we can find pre-configured solutions for us to utilize. Once I have a VM up and running, I'll explore cloud storage and see how we can store both data and files in the cloud. I'll then move on to Google App Engine, our serverless solution for running applications. And finally, we'll finish up with access management and Google Cloud. The main interface for Google Cloud is through the Cloud Console. This is acting as a hub for the majority of the work that we're going to do within Google Cloud. I'm going to explore this interface and explain where you can find most of our common products. Since we're going to cover a lot of topics today, I think a practical demonstration is the best way of seeing how each of these products work. So let's hop over to the Cloud Console now. And here we are. This is the Cloud Console. The Cloud Console is made of three main parts. In the center is our dashboard, and this gives us an overview of our cloud account. We can see information on the project we're currently working on, any API calls that are happening. If we have resources provisioned, we can see an overview here, in addition to monitoring of resources, our billing estimates. This dashboard, like many dashboards, is customizable, and we can rearrange the elements to suit what we want. On the left-hand side, we have the Quick Access menu, where we have organized the most common features within Google Cloud into their logical connections. At the top, we have Marketplace, Billing, and Administration, which also includes your access management, compliance, security center, and your migration through Antoth. Next, we have the Compute section, where we have Compute Engine, where we can provision our virtual machines, the core of Google Cloud. We also have our serverless option, App Engine, and our container option, Kubernetes Engine, in addition to Cloud Functions, Cloud Run, and VMware Engine. Below that, we have storage, where we would have our bucket storage, in addition to file store and our data transfer. Below storage, we have our databases. We have multiple database options within Google Cloud. For today's session, we're going to look at SQL, but we have both relational and NoSQL options within this category. We then have the networking section, where we can create our virtual private cloud networks, configure services such as load balancing and CDNs, configure hybrid connectivity to on-prem cloud connections, in addition to our network security and other options.
Below networking, we have operations, where we can access tools that help us monitor and track the resources that we use within the cloud. And as we move further down through the list, we see other options that are available to us, but they are beyond the scope of what we're going to cover today. In the top bar, we have our burger menu to toggle on and off our quick access menu. We have our project information, where we can see all of the projects that are provisioned for our account, in addition to the ability to create new projects. We have our search bar, which we can use to find products and features and documentation rather than searching through our quick access menu on the left. And on the right-hand side, we have a couple of options here. We have the account information. So this is a dummy account I've set up for this session. We have our settings, we have some notifications, and then we have this option here, which is our Cloud Shell. So Google Cloud provides us with a powerful UI here to interact with our cloud account, to provision resources, and to configure those resources. But behind all of this is a Linux operating system. And while coming from Microsoft Windows, you may be more comfortable using the UI, you also have the ability to use a command line interface. Practically all of the things you can do within Cloud Console can also be done within Cloud Shell. However, as you become more comfortable with Google Cloud, you may see that Cloud Shell provides just a little bit of a quicker route to get resources provisioned, especially if we're talking about provisioning fleets of virtual machines or programmatically configuring the resources that we have. It is possible to do this through the UI, but depending on the size of your infrastructure, this may become a tedious task, and to be able to do it programmatically may be far more efficient for your infrastructure. Okay, let's shut down the Cloud Shell for the moment. We won't deal with that a huge amount. And let's go back to our menu and have a look at our first section. Okay, so as I mentioned, the core of Google Cloud is our virtual machines. So let's go and provision a virtual machine and see the process for this. So over on the left-hand side menu, I'm going to go to Compute Engine. I'm going to click on VM Instances. And since this is a new account, there are no existing VMs in our option. So let's click on Create Instance and actually spin one up. So when we click on Create Instance, it's going to provide us with our configuration screen. The first thing I want to do here is I want to give it a new name. I'm just going to call it My VM to begin with. We can add labels if we wish, but I'm not going to at the moment. We are going to select our zone. Now our region and our zone will dictate where our VM is actually hosted, what data center it's hosted at. But it also has a couple of other effects on our virtual machine. So we can see on the right hand side here, our monthly estimate for this virtual machine with this configuration running this operating system in this location is $25.46. If I were to change this to Europe, I can see that to run it in Europe North 1, my monthly estimate has now jumped up to $28. So the location of your VM can actually affect the cost. Another thing to consider is, if I go back to North 1 here, we'll see that in our machine family, we have general purpose, compute optimized, and memory optimized. What we're missing is our GPU enabled VMs, which aren't available at the moment in every region. So if you require a GPU enabled VM, this may dictate where you have to have your VM hosted. And the last is, I suppose, the geographical logic of your VM location. If all of your client base is in Europe, it doesn't make a huge amount of sense to have your VM hosted in America or in Asia Pacific, unless there is a overriding cost or feature that you cannot get in the region you're looking for. So let's return it back to here. We have US Central 1, and then within that we have several zones. I'm going to leave it at Zone A. And the next section we look at is our machine family. The machine family can also dictate the cost of the machine we're looking at. We have broken up our machine families into a couple of subsections. So we have general purpose, compute optimized, memory optimized, and GPU. And within each section, we can have other options available as well. And this does affect the cost of your VMs. You can see here, if we go for an E2 series CPU with 2 virtual CPUs and 4 gigabytes of memory, we're looking at our $25.46. But if I require a machine with a GPU, and you can see our minimum option here is our 12 core, so it's more virtual CPUs than our previous option. It's also more RAM, because we've got 85 gigabytes. We also have access to our NVIDIA card, but it's more than 100 times the monthly rate than our other machine. So it's important, as you're trying to optimize your costs for Google Cloud, that you pick the machine that suits you best. If I go back to general purpose, I can see that I've got a couple of different series. So E2 is our economical option. This would be generally used where the platform for the CPU isn't a dedicated requirement. If you explicitly need Intel Cascade Lake or you need an AMD processor, well, then we have options here. We also have an older option for Skylake CPUs. But if you're not worried about which CPU you're picking, E2 is your most economical option because it'll pick the best CPU available, but it's based off availability, so it may change depending on which machine you're running and at what time you're provisioning the machine. Within that series, we have multiple types. So we can have our shared core here. So we can have quite a low machine here with 2 CPUs and 1 gigabyte of memory. We also have standard types where we have larger amounts of memory and our CPUs scale upwards. We also have high memory options, but within this category. So not the memory optimized family up here, but the high memory options within a general purpose machine. We also have compute or high CPU optimized as well. So we can change. And as we change through the families here, you can see that the cost will also increase to reflect the higher standard of a machine that you're using. Let's return back to our original here. The next section I want to have a look at is the boot disk. If you're coming from a Microsoft background, a Debian Linux boot disk may not be the most friendly disk to begin with. If you're doing a lift and shift and you just want to replicate your existing infrastructure, what I would be advising is that you click on Change here, and we can see the options of operating systems that are available within Google Cloud. And at the bottom, we have our Windows Server. So within Windows Server, we have a selection of different Windows Server versions, running all the way from, I think the oldest one we have here is 2012, all the way up to our current 20H2 server. And depending on which you pick, obviously that may dictate what is the required specification for your VM machine. But let's pick 2012 or 2 data center, and we'll leave this as our 50 gigabyte disk, and we'll click select. And you can see by changing from a Debian operating system to a Windows operating system, we are incurring a larger cost. And if I click on details here, it gives me my breakdown. So I can see that my CPU is costing $24. My larger gigabyte of disk, because I only had 10 gigabytes when I was in the Debian operating system, is costing $5 a month. And my license fee is costing $33 a month. Other options we can have here is our service accounts, our firewalls, and what's also useful here is our startup scripts. The next section I want to look at is our management, security, disks, networking, and sole tenancy. If we were configuring a machine that required a startup script, what we would do is we would give the location of our value here, which would be the file location for our startup script on the actual drive or in our cloud storage, and we dictate our key value here to be startup script. But we're not going to do that today, it's a little bit beyond. Another option we can have here is our preemptibility. Now, I'm not going to select this at the moment, but our preemptibility it's a way of making the cost for your VM more economical. A preemptible VM is a VM that will only run for a maximum of 24 hours and can be shut down at reasonably short notice within those 24 hours by Google Cloud if resources are required. So this is great for workflow that can be either is short in duration or can be interrupted mid workload. The cost savings for preemptibility can actually be up to 80% of the normal on-demand cost. So if you're looking for a way to make your cost budgeting more efficient, absolutely preemptibility may be an option if it fits the workloads that you're running. I'm not going to select it here because it does affect some other elements in the startup. And the last thing I want to show before I provision this machine is at the very bottom here, we have the equivalent command line and rest. So I showed you in the Cloud Console that we have our Cloud Shell option up here at the top, and that it is possible to do all of what we've configured here in this UI through a command line interface. And if I wanted to learn how to do that while configuring my normal VMs through the UI, if I click on the command option here, I get the complete breakdown of how to provision this machine for this project with all of the options that I've selected in this UI. And this can be used to create a template to create other machines of the same standard. It can also just be used as a learning tool to figure out, oh, well, this is specifically the version of Windows Server that I'm running. You can see here that it's again, Windows Server 2012 or 2 DC, but also there's the updated version. It was updated on the 9th of March 2021. I can see the size of the disk here and I can alter that. And it gives you a little more insight into the specific commands that are used to provision these machines. But it's not necessary if you don't want to use it. So let's close this and let's create our machine. So let's see, our VM is going to spin up. It takes a moment to spin up. Usually our VMs will spin up in about 30 seconds, obviously depending on the complexity of the machine. If you have a very high performance machine, it may take a little bit longer to provision all those resources, but a normal standard machine, you saw it span up pretty quickly. So here we have the name of our machine, the location where it is. We have our internal IP access. We also have our external IP access. And we have a way of connecting directly to the machine through RDP. So let's demonstrate the RDPing into a machine. So the first thing I want to do is I want to set my Windows password. This will just create a Windows password that allows you access based off the user that you're logged in as in Google Cloud while this is provisioning. So here's our password for accessing this machine. If you required to create this VM and then join it into an existing domain controller, you absolutely can do that through the standard commands you would do on an on-prem machine. But like with an on-prem machine, you would want to probably log into that machine as a local user first to add it to the domain. And that's something that we can do through Google Cloud as well. So once I've created my new password, I'm going to need to actually log into that machine. And we're going to do that now. So let's log into our virtual machine. So I'm going to close this box here. I've copied my password and I'm going to download the RDP file because that's the way I like to interact with my machines. I'm going to open up my value. I'm going to put in my password. And you can see here that we're logging into our virtual machine. And it should give me my 2012 Windows interface. Since the server manager is going to spin up, although I don't need that. So I'm just going to shut that down. And you can see here that I'm logged in as the user that I wanted. And I have all of the normal Windows tools that I'd be looking for, but I also have my Google Cloud SDK shell installed as well. And that just allows me to interact with Google Cloud directly from this virtual machine, which, if you think about it, makes a lot of sense. The machine has been hosted within Google Cloud. I should have full access to all of the features and products that are there. So that's a very simple spin up of our virtual machine. For today, we don't really have much time to provision much more than that. But as I mentioned, we have plenty of courses that dive deeper into what we can do within Google Cloud.
I'm sure you noticed in that last demo that Azure and Compute Engine virtual machines have a lot in common. And this really makes a lot of sense. They both aim to replicate an on-prem machine. Both Compute Engine and Azure VM allow you to choose and configure the RAM, CPU, and GPU for the machine. Both offer a wide range of operating systems. Additional virtual disks can be added to virtual machine types. Ephemeral and static public and private IP addresses can be used for both types of instances. Both instance types can use startup scripts to configure our VMs. But there are some differences between Azure VM and Compute Engine. The first is spin-up time. It typically takes Compute Engine instance about 30 seconds to start. An Azure VM instance can take minutes. Azure VM offers temporary instances called low priority instances. And Compute Engine offers similar instances called preemptible VMs. Both provide similar functionality, but they have a different pricing model. With Compute Engine, preemptible VM pricing is fixed. Although, depending on the machine type, preemptible VM prices can be discounted nearly 80% of an on-demand rate. If not reclaimed by Compute Engine, preemptible VMs run for a maximum of 24 hours and then they are automatically terminated. Also, if you use a premium operating system with a license fee, you will be charged the full cost of the license while using the preemptible VM.
Okay, so we've seen how to configure a virtual machine by specifying all of our requirements ourselves, and that takes a little bit of time. What we do have to help us with this scenario is the Google Cloud Marketplace. The Cloud Marketplace is a place where we can find pre-configured solutions in addition to data sets and other utilities that we may want to use. If we are just looking for a standard virtual machine to be spun up, something pretty common, like in the example we're going to use here is a web server, then this may be a great way of saving your time and effort by picking a pre-configured option. So we have many options here. If you look on the left-hand side, we can see it's broken down by category. We can also see some featured elements here. But what we're going to do is we're going to search for IIS. We're not looking for a space station. And we're going to go for this one here, Microsoft on Windows 2012 or 2. And you can see we've got two versions here. We've got Secured MySQL or just IIS. So we're going to go for the top one. And when we click on it, we're going to be presented with our options and information about this content, or about this virtual machine. So you can see it gives the breakdown on the pricing, the usage fee for both the server plus the actual operating system, the number of CPUs and memory we have in our machine, how much persistent disk storage, and our sustained usage storage as well, or sorry, our sustained usage discount. It also gives us some information on what the actual system is we're booting up. So we click on Launch here. We get our deployment name. We get the location where we're going to deploy it. Again, we can customize this here, but by customizing it, we're going to alter this price up here. So let's leave everything as standard for the moment. I'm going to accept the terms and conditions. You usually only do this for the first time you launch something to the marketplace, but I will do it here. And we're going to click deploy. And so what this is going to do is it's going to create a new virtual machine for us with the specifications that we have defined. So 15 gigabytes of memory, 4 CPUs, 127 gigabytes of storage. And it will make sure that IIS is installed and running on this server. So you can see here, it's running through all of the startup scripts that we have to make sure that everything's up and running. We have our content working here. So we'll check back in a moment to see when this is spun up, just to verify that it's working. Okay, so our virtual machine has spun up fully, and I've been provided with this information here. So we can see we've got the check mark here to verify it's spun up fully. I can see my external URL for IP address, for this instance. If I click on this and say, yes, I want to go there, it'll give me my IIS landing screen. So that's perfect. We know we're accessing that server. We can also see we have our instance name, our location, the type of machine, and other information. I can also RDP into this server if I wish, the same way I did into my previous virtual machine, but I'm not going to in this example. If I go to my virtual machine instances, I'll see that I have 2 virtual machines now. Once this loads, I have my VM from our first example where we created the VM ourselves, and I have my IIS standard here. One thing that's worth noting with Marketplace is, depending on what you're looking for, so if I looked here for WordPress, we get multiple options, okay? The reason why we have multiple options is because different vendors will put on their version of that solution. So you are not restricted to a specific vendor. Depending on what you're looking for, there may be options you can look for that are more specific. So depending on what operating system you're running, or perhaps using, for example, here we've got the secured WordPress, but also we then have WordPress on Server 2019. So there are different versions that can be instantiated. But that is our cloud marketplace. Very handy for spinning up quick solutions when you don't want to go through the configuration process yourself. So the next thing I want to look at is cloud storage. Cloud storage is the way that Google Cloud stores information. We store information as objects, and we keep our objects inside a bucket. So what I want to do now is I want to go down to the storage section in my quick access menu, and I'm going to create a bucket. This bucket needs to have a globally unique name. So the easiest thing for me to do here is to paste in my project name, because I know that that's a globally unique identifier. And I'm going to click continue. If you pick something which is not globally unique, you'll be given a warning. So if I just type in here, for example, my bucket, I can only imagine someone has used that already. It will tell me this name has already been taken. So let's pick one I know is not taken. I'm going to leave this as multi-region. So we have different location types for our data. And if we want our data to be served at a global rate, high availability is usually the most sensible option. So multi-region will split our data or duplicate our data across multiple regions in a particular territory, with our territories being either the Americas, Europe, or Asia Pacific. And just like with compute engine considerations, we probably want our data to be geographically close to our big user base. So I'm going to leave it at the Americas for the moment. And I'll click continue. We have different storage classes for our data. Standard is probably going to suit most projects to begin with. Nearline, cold line, and archive are for data that's not accessed as regularly. And they have cost implications for storing in different storage different storage classes, but for the moment we're going to leave it as standard. I'm going to change. So with access controls, we have 2 options here. We can have fine-grained, which is actually the one I'm going to use for this, or we have uniform. So uniform access means that everything inside that bucket has the same access rights as each other. Now that mightn't be what we want. Fine-grained is, as the name suggests, a fine-grained access solution. We can decide on specific items whether they are publicly accessible, so they're accessible over the internet, or whether they're internal only, or whether only certain people or certain projects or certain applications can access them, which I think is a much more secure way of approaching our access to the data that we host. So I'm going to leave this as fine-grained and click continue. And I'm going to leave these options as they are. So I'm just going to click create now. And now my bucket has been created, but I need to add a thing to my bucket. I need to have an object in there to verify that it works. So what I'm going to do is I'm going to go upload files. I'm going to go to my desktop. I'm going to click on my cat JPEG and I'm going to let it upload. I mean, you can now see there that there is my cat option there. We can see the size of the data, the type of information it is, when I uploaded it. We can also see here it's not publicly accessible. So if I were using cloud storage to host files that I wanted to be served via a website, I would need to be aware of their accessibility before I host them on the website. And that's actually what we're going to do here. So the first thing I need to do is I need to go into this cat object, and actually I want to make this public here. So the way I'm going to do that is I'm going to go to edit permissions. And here you can see I've got my project entity, I've got my user entity, and these are verified people with authentication into our Google Cloud accounts, but I just want public use. And here I can set this as public. And you can see everybody has access to the public file, but they only have read access. And I'm going to save that. And what will happen now is I now have a public URL here, which I can copy and I can open up another browser window and I can put that in and I will get access directly to that image. Okay, the next thing I want to do is I want to actually host this on one of my VMs. So let's go to compute and to my VM instances. And I've got my two VMs here. I've got my VM from my compute engine, the first one we created, and the one I created from Marketplace, which is the one I want. This is the one that has IIS on it. So if I go to the VM, you see here we are spun up. I'm going to open up my browser, my Explorer, and I'm going to go in to the hard drive, and I'm going to go into inetpub, which is where IIS hosts from, and I'm going to go into www root. What I want to do is, this is the home page for IIS. If I go back here, so this is the home page for our IIS. So all of the data that comes up when we first load up IIS is in this page. So if I go back to my VMs and I copy this and I open up a new tab and I paste it in, we'll see we have Windows Server, Internet Information Services. So this image here is this IIS 85 image, which I opens up, you can see there. I'm going to replace that with the cat. So how I'm going to do that is I'm going to open up this file here. And I'm going to put the location in cloud storage of my cat image to there, so that when I refresh the page in the browser, it should appear as a cat rather than a standard image. So I need to go back to my console. I need to go to my bucket. I need to go in here and I need to get the copy of the URL so that when I come back, all I need to do is I need to change this image here to my Google Storage API. And that should be all I need to do. It'll load up the web page running off this VM, but it'll get the image from my cloud storage bucket. So I'm going to save the page. I need to remember to save it as a HTML page, not a 2 to 1
text file. Okay, and I click save. And I do want to replace it, yes. Okay, so now I have updated my image. If I go back here and I go to my IIS server again and I refresh this, we should get our cat picture. Okay, so we're pulling that image from our Google Cloud storage as opposed to from the virtual machine where the server is running from. So we've just seen what Google Cloud can offer for cloud storage. In comparison with Azure, the units of deployments are buckets in Google Cloud and containers in Azure. Cloud storage creates a globally unique key for identification, where Azure's identification is at the account level. Cloud storage allows for native versioning of all items in a bucket. In blob storage, you would need to define lifecycle rules or use Azure automation. Cloud storage also allows you to configure lifecycle management policies on individual buckets and provide automatic object versioning. This allows you to track all changes to objects, and you can restore individual objects from archive versions. Google Cloud deployment localities are multi-regional, dual regional, and regional, whereas Azure Blob Storage uses zonal, regional, and dual regional. However, in Azure, dual regional storage is called geo-redundant storage. It's important to be aware of these points when using Google Cloud. Okay, so we're moving through this. We've created a couple of VMs. We've created a cloud storage bucket and we've put an object inside it. So the next type of storage I want to look at is a database. Now, for any of you who've set up servers before, setting up and maintaining a database, in addition to the data and user maintenance, can be a tedious task. And Google Cloud offers a managed service called Cloud SQL, which helps you with this. So we can create an instance here, which will create a managed instance of the database engine that we choose, and leaving only the user and data maintenance in our responsibility. And the actual maintenance of the database engine itself is taken off our hands and managed by Google Cloud, which can save hours and hours of time. So we've got a couple of options here, but for us, the most relevant is going to be SQL Server. Okay, so we need to create a SQL Server instance. We need to do a couple of things here. So the first thing we need to do is we need to give it an instance ID. So my Cloud SQL DB. I'm going to give it a password. Now I'm going to give it a super rudimentary password. Obviously, I wouldn't be recommending people use the word password for their password, but for us, it's fine here. I'm going to leave my database version as 2017 standard, but we do have other options that are here. My regionality, I'm going to leave as US Central 1, but I can also say that this is going to be a highly available database. So rather than creating our highly available cluster by hand or in a cluster of virtual machines and having to manage that and having to manage the failover instance, we can do all of that by a simple option button within Cloud SQL. We can specify the zones we specifically want our database to be in, both the primary and the secondary zone, but I'm going to leave them as default for the moment. We can also look here at our storage. So we have our machine type, and we can choose a couple of different types of machine here. We can go with high memory, or we can go with standard or with lightweight. For high availability, usually we pick a high memory machine as well. We can also customize the machine to scale up or scale down the amount of CPUs and memory that we're using, but we're going to leave it at a 8 gigabyte. Actually, we'll leave it at the 4 CPU, 26 gigabyte. We'll leave that there. We can choose the type of storage that we want. And so we can have 100 as our standard, and our storage type is SSD. But we can also increase this. We can go to custom here, where we can choose our number of gigabytes all the way up to 30 terabytes of storage. But we'll go back to 100 gigabytes. We also can enable automatic storage increases. So as we approach our capacity for that database, it will automatically bump it up to the next level, meaning that it's taking the maintenance of what happens when we hit capacity in our database away from us. Now, you store more information, you have a bigger storage request on your database, it's going to affect the cost of your database, but it
does remove the headache of running out of storage, especially on a live application where your users may be affected. We can choose our connections here, and so we can have private IP only, or we can have public IP. We can add authorized networks here. I'm not going to do any of that at the moment. We can have authentication, where we can pick an Active Directory domain that we want to pull in. Now, at the moment, that's only in preview, but eventually it will be incorporated fully into our system, meaning that you can replicate the Windows authentication that you would have from your on-prem Active Directory in the cloud as well. We can look at our backups, and we can see that we've automated our backups here, so they could happen within this window in our UTC time zone. We can choose the maintenance when we want that to happen. We can have flags and parameters and our labels, but let's leave all of this here. We can also see that this is our summary of our database. We're hosting it in US Central 1. We're using SQL Server 2017 standard. We have a 4 CPU, 26 gigabyte, 100 gigabyte configuration. Our network throughput is 1000 of 2000 megabytes. We have a 48 of 240 read throughput and a 48 of 240 write throughput, with our IOPS being this. We allow public IP, and we have automated backup, and it's a highly available. So if I were to switch that to single zone, you can see that it does affect it here as well. But let's go back to highly available. Okay, so let's spin this up. And this will spin up in a couple of moments. Now, what's happening in the background is it's actually provisioning this database for us. But what we get to preview at the moment is we get to have a look here, and we can see our connection. So we have our connection name to connect to our database. We can see the overview here of our content. We can see our utilization of our CPU. So we have a dashboard here that will actually enable us to have a high level view of what's happening. We can also see the logs for the database as well. So I'm going to check back in a moment when this has fully spun up. Okay, now our database has spun up. So we need to go and create a user. So I'll add a user account. My username here, I'm just going to use database user. And I'm going to set the same wonderful password I did before, of just the word password. Add. And I can see that I actually have my user there. In connections, you can decide which applications in other projects or which applications in your own project have authorization to access this database. I'm not going to configure this here, but we will be able to add in specific applications to allow access or to block access from. And the default you can see here is that apps in this project, they're all authorized. So if we create an App Engine application, it is authorized to use this database. We can also have a look at the databases that we have, which at the moment we haven't got any. We just have the default ones that are included in SQL Server, but we can create a database here if we wish. We can also look at our backup schedules or backups that have been taken, which we've only just spun up recently, so we haven't actually got any backups. And we have our operations as well of creating the user, just been created there, and when we actually created the database. Okay, and that's our SQL Server. So if we go back to our main instance here, we can see that our resources are starting to fill up. We have 2 VM instances created. That's our first VM we did, plus our one we did from Marketplace. We have our storage bucket, and we have our SQL Server here as well.
Again, I hope you notice the similarities between Azure SQL and Cloud SQL. Both are managed relational database services that use commercial relational database management systems. Both Azure and Google Cloud will manage the infrastructure of the databases to include the instances, backups, updates, and failover. As the user, you're still responsible for data management, schema construction, and user management. Reads and writes can be scaled differently. For the write database, the instance can only be vertically scaled. You can make a single write database larger. You can horizontally scale reads with read replicas and put them in different zones or availability zones. A failover replica can be built into another zone or availability zone. The cloud provider is responsible for the failover process. Let's compare Cloud SQL and Azure SQL. In Azure SQL, you can enable encryption of data at rest. Cloud SQL customer data is encrypted by default when on Google's internal networks and when stored in database tables, temporary files, and backups.
For our last demo today, we're going to look at something a little advanced. App Engine is Google's serverless application platform. Google App Engine applications are easy to create, maintain, and they'll scale automatically as our traffic and data storage needs change. With App Engine, there's no servers to manage. We simply upload our application and we're good to go. App Engine natively supports things like load balancing, microservices, authorization, SQL and NoSQL databases, plus a whole range of other features. So it really is a way of taking the management of your application off of your responsibility and letting your cloud provider handle it. App Engine has two environments. We have our standard environment and we have our flexible environment. And they support a host of programming languages between the two of them, like C#, Java, Python, PHP, Node.js, Go, and more. For today, we're going to create an App Engine flexible environment. We're going to create a .NET Core application, and we're going to send that to our flexible environment and be able to run it from there. Now, as I said, this is a little bit advanced, this section, and the reason why it's advanced is we're not going to use our Cloud Console. We're going to use Cloud Shell. So I'm going to let that provision up. I'm going to say continue here. And I'm just going to close that menu out to give me maximum space. So we have a couple of things to do in this demo. The first thing is we need to actually create our .NET application. And that's actually very simple. It's a couple of lines of commands and it works for us. Once we've created our application, we need to package it. We need to publish it so that it's ready to go out into wider consumption for a client. But if we wanted to appear on App Engine, we need to add some additional files. And these additional files are basically just the instructions on how to containerize your application, so how to put it into a Docker container, and how App Engine is meant to run this application. So let's start this process. So the first thing we need to do is we need to verify what version of .NET we have. And we're going to do that by running this command. We're going to type .NET -- version. And what this will return is the current available .NET version for our Cloud SDK. And you can see there it is 3.1.407. The next thing I want to do is I want to disable the CLI telemetry from my .NET application. It's beyond the scope of this demo to explain what that is, but for the moment, assume it is a required step. So the command is .NET _ CLI _ telemetry _ optout equals 1. Okay, so that's the second step. We're now going to run the command to actually create a brand new application. So, don't need caps lock. So .NET. And we're going to say it's going to be a new application. It's going to be a .NET Core, so Razor. And the name we're going to give it is, well, we'll go with something that's pretty unique. We'll say it's Owens ASP Net Core. Okay, so it's unlikely that this is existing somewhere else. Okay, this is just going to be the name of our application. It doesn't have to be globally unique, but we've picked something that's unique to this. And when we run this command, what's happening is it will go and create a skeleton.NET application for us based off of the 3.1 SDK that's available inside our Cloud Shell. Okay, and you can see really what we're looking for. It has a couple of information here. It also talks about disabling telemetry. But really what we want is we want to make sure we see restore succeeded, which we did. So first step done. The next step I want to do is I want to verify this application works. So I've created a template but I need to verify it's working. So I need to navigate to that actual applications folder. So I'm going to use CD for my change directory command. And I'm going to go to the name of the folder, which is owns ASP.NET Core. I'm going to press enter. Now that I'm in the folder of my application, I'm going to run my application. And the way we do this is it's another .NET command. So this .NET command, as you might imagine, is run. And I want to point this .NET command at a specific web address so that it's the .NET Core application is a simple web page. So I want to point it at a web page that I know I can access. So the perfect one to do here is our local host. It's not actually going live on the internet yet. We're going to test it locally on my VM and see how we get on. So we're going to run this and we should see some outputs coming on the screen now that explain that it's up and it's running. Okay, so we can see here we have it's listening now on localhost port 8080. And if we want to shut it down, we're going to do Control-C, which we're not going to do just yet. We're going to test it first and then we're going to shut it down. So if I want to test it, I'm going to go over here to my web preview. So it's this icon over here on the right hand side. I'm going to click on that and I'm going to go to preview on port 8080. We should see our simple web application that says it's owns ASP.NET Core app. That's perfect. That's all I want to see. This is what the skeleton application looks like. So I can shut down this page here and I can go back here and I'm now going to run my Control-C command to quit out of there. So in the process of actually creating our .NET application, we've done the first two steps. We've created the application using our .NET new command. We've run the application using our .NET run command. So the next thing we need to do is we need to publish it. We know it's working. Let's package it up and get it ready for the world. So we're going to go .NET publish C release. So we're going to publish it as a release version. And what's going to happen is it's going to create the required DLLs to allow this application to run in places other than on my Cloud Shell here. And it's created three new things. It's created a DLL for the actual application. It's created a DLL for the views to actually kind of see the interface of it. And it's created a publish folder. And this is where I want to go. I want to go to my publish folder here. So the way I'm going to do that is I'm going to use my CD command, my change directory command again. So CD, I'm going to go bin release .NET Core app and lowercase p publish. So I want to go in here. And this is just the new folder that's been created. It's the same folder that is here. So I'm going to go in there. And we are almost ready to get this working. So I know my application works locally. I have published my application, which means that any of the other ancillary elements I would need to get my application up and running have been now included. I now need to add two files to this folder to make sure that when App Engine receives the application, it will be able to process the contents. So the first thing I need to do is I need to create what's called a Docker file. And the Docker file is going to explain how this container is meant to be run. So I'm going to create my file using the touch command, touch, and then Docker file. And this file name is a standard file name for creating Docker files. And now I'm going to use my text editor, which in Cloud Shell, the one I like to use is Nano. It's nice and it's simple. And we're going to move to Docker file. And at the moment, it's empty. So what I'm going to do is I'm going to paste in the contents I need, and then I'm going to explain what each of those lines mean. Okay, so I've now pasted in my applications, not my applications, the text for this file. So our base image is going to be an ASP Core 3.1. That's fine. That's basically just telling Docker what our underlying image is that our container is going to sit on top of. We're going to add this as an application. Our environment is going to be an ASP Core, and the URL will be whatever URL is actually created by App Engine, and whatever is the appropriate port. Our work directory is also going to be our app directory. And our entry point is going to be, this is a .NET application, and here's the DLL you want to have a look at. And actually, that's incorrect, because it's not hello world. I called mine own. So we need to change that to owns ASP core. So it matches the name of my project and the name that was created. So if I'm happy with all of those lines of text, I'm going to use Control X to save my file. And then we're going to go Y to say, yes, we want to keep the same file name. Okay, so that's my Docker file created. The Docker file is telling our container creation tool how to actually package this up, what is required as the underlying resource to be able to run this application. The next file I need to create, and I'm going to use my touch command again, is an app.yaml file. And this is what App Engine is going to use. So the app.yaml file will define what type of App Engine environment we're using, whether it's standard or flexible. And it'll tell me, or it'll tell App Engine what type of runtime we're using. So it's quite a simple file here. It's only 2 lines, so I'm going to type them out. The first thing, as I said, is we're going to mention our environment. So env for environment. Oh no, that's not what I want. Sorry, I need to go into Nano to edit it. So it'll be env for our environment, and I'm going to say that's going to be flexible, or flex is the way it's defined here. And my runtime is going to be custom because we're using .NET, and that's all that needs to go in there. The app.yaml file is a super simple file. So we're going to go Control X to save it, and Y to say, yes, we want to keep the same file name. I now have all of the bits I need to get my application up and running. I've created my application, and I've tested it locally. I have published my application, so I've added in all the extra bits, the DLLs that I need to get it working. I've created my Docker file so that we know how to create a container for this application. And I've created my app.yaml file so that App Engine knows how to take that container and run it in App Engine. And they're all the elements I need. So the last thing I have to do is actually just deploy this application to App Engine. And our command for that is going to be gcloud app deploy. And I'm going to give it a version number. I'm going to say this is version 0. Obviously, if this wasn't the first version of this application, we probably need to change that number, but for us, it's fine as 0. And it's now going to ask me, do I want to authorize this API call? And that's fine. It's just saying, are we allowed to use your credentials to make this call? We have to do that to be able to use the App Engine API. The next thing I'm presented with is the region that I want to add my content to. So I'm going to add it to Europe West. So this value here, just because locally or geographically, that's the most closest venue to where I am. So I'm going to say option 9. Obviously, if you were somewhere else, you would pick somewhere else. But for me, Europe West works. And now my application is going to do all the necessary steps to create it. The first thing it's going to do is it's going to create the template before it actually pushes it to App Engine. And it's going to present me with those options just to make sure everything's correct. So you can see here, our descriptor, so how we're going to describe our App Engine app is written in our app.yaml file, and we've written that so we know what's there. The source for our application is in the publish folder, and that's good. Our project is the project we're currently logged in as, and where it'll end up is this URL here. This is how we're going to be able to run our application. We go to this URL. So yes, I'm happy with everything there. So I'm going to go Y. And now the service is going to do all of these things in the background to get our project up and running. So this is going to take a minute or two. So in the interest of time, I'm going to check back once this is finished. Okay, so our application has run its course and everything's finished. And you can see here, you can view your application by typing the gcloud app browse command. So we're going to do that. So we're going to go gcloud app browse. And this should open up a new, actually it'll give me my URL here. And you can see that this is running from AppSpot, which is the URL that our App Engine apps run from. And you can see that we have our application here. So we have put our, we've taken our application from command line here, where we just created it, and then we ran it locally, to packaging it up for App Engine, and then deploying it to App Engine. And now we have a version live on the internet. If I wanted to update this application and make different versions, that's absolutely possible. It's just beyond the scope of what we have today. Okay, so that's the end of this demo.
App Engine Standard Environment, App Engine Flexible Environment, and Azure App Service offer similar PaaS functionalities. All three can use autoscaling as a way of leveraging resources as needed. All three are available in the US, Europe, Middle East, Africa, and Asia Pacific regions. Let's look at the certain features and see how they differ between the two App Engine environments, as well as Azure App Service. App Engine and Azure App Service offer a wide variety of runtimes. App Engine Standard Environment supports fewer runtimes due to the lockdown environment that the standard environment supports. App Engine Flexible Environment and Azure App Service both support custom runtimes. App Engine Standard Environment comes with a free tier. Azure App Service has a free tier for the first year. There is no SLA provided for the free service plans on Azure. App Engine Standard Environment does not support network controls. Only IP endpoints are exposed to the internet. App Engine Flexible Environment and Azure App Service both support using virtual networks, VPC and VNet respectively. For application authentication, Azure App Service supports Azure AD and EasyAuth. For App Engine, Google supports a variety of identity providers using Firebase. All three options support the use of task and message queues. For Google Cloud Services, App Engine can use Cloud Task API or PubSub, which is a push-pull managed message queue. Azure App Service supports WebQueue Worker only, which is a pull queue. Pricing for App Engine Standard Environment is based on instances per hour with a free tier. App Engine Flexible Environment and Azure App Service prices are based on vCPU per core hour, memory per gigabyte hour, and persistent disk per gigabyte per month. So, we've looked at some of the main products with Google Cloud that you may use when you start to bring your infrastructure over. But what we haven't looked at is how do we authenticate our users? The main mechanism to secure user authentication and permissions in Google Cloud is IAM. If you're coming from an Azure background, you may be more familiar with using Active Directory. Let's have a look at the differences between the two approaches. Access management is handled differently in Google Cloud and Azure. Google uses service accounts to control service-to-service authentications. For Azure, you use role-based access control, or RBAC, to control who has access to Azure resources, what can they do with those resources, and what area do they have access to. For Google Cloud, user identities are managed outside of Google Cloud. For example, Workspace or Gmail accounts can be used to manage identities. It's more common in Azure to have user identities managed by Active Directory tenants. If you already have an on-prem AD or an Azure AD-based solution in your organization, then here's some good news. Google Cloud can provide federated access management of your users without the need to create additional Google identity accounts. This allows your organization to migrate projects to Google Cloud while maintaining existing AD tenants and DNS domains. Google Cloud also supports AD's version of IAM for Windows applications, which allows you to use your existing org structure. Finally, Google Cloud offers a managed service for Microsoft Active Directory. This is a highly available, hardened Google Cloud service that is running AD on Windows Server and allows you to manage authentications and directory ops for AD-dependent cloud apps. The advantage of using this managed service is that it automates best practices to take work off of you. It also automates patch updates. It provides easy domain join with additional client-side config as well as automatic organizational unit creation for group policy management. For Google, policies are a list of bindings that set up a user's permissions by the role applied. In Azure, policies are also used to bind a list of members to a role. The user role pairings on a resource determines a user's permission in Google Cloud. In Azure, ORBAC determines the role's permissions. Users are assigned to a specific role. Google uses predefined roles which are built to match job roles. Azure uses role definition. A role definition lists the operations that can be performed. Roles can be high-level or specific. That concludes today's session. Moving cloud provider is a big undertaking with many possible pitfalls. But hopefully, through the demonstrations and explanations that I've covered today, I've shown you some of the potential that Google Cloud can offer. I hope you'll be able to bring your applications and systems to Google Cloud, and you'll be able to do so with confidence based on the training that is available from Google Cloud. Thank you for tuning in. Please visit cloudonair.google.com for more hands-on learning, training, and demos from Google Cloud experts. See you next time.